As we previously said, in real life, most of the experiments do not have equally likely outcomes. So what do we do? Next, we will discuss the empirical approach, which is a method of finding the probability of an event defined for an experiment with not equally likely simple outcomes. Again, the question that we will try to answer is about how to find the probability of an event. And we already understand that for every event there is an experiment for which there exists the sample space, which consists of all possible simple outcomes. In this section, we consider only those experiments for which the simple outcomes are not equally likely. Let our experiment consist of throwing a cone in the air and recording how it's landed. A cone is a simple three-dimensional object that can only land in two positions, upright or sideways. So the sample space of the experiment has two simple outcomes, U for upright and S for sideways. It is pretty clear that these outcomes are not equally likely, so the classical approach wouldn't work here. We have a strong intuition that the probability of the cone landing on its side is more than the probability of it landing upright. So the goal is to find the probabilities for each of the outcomes. One way to compute the probability of each outcome is to look at the past experience of tossing a cone. For instance, in this case, last time I flipped a cone 100 times, I had the following frequency distribution table. None of these numbers look like they can represent the probability of an event. But if we construct the relative frequency table, then we will start seeing that the relative frequencies look a lot like probabilities, aren't they? The empirical approach is also called the relative frequency approach. In summary, the empirical approach consists of performing the experiment many times and constructing the relative frequency distribution table, and then interpreting the relative frequencies as the approximations of the probabilities of the corresponding outcomes. In our example, 0.94 is approximately the probability that a cone will land on its side, and 0.06 is approximately the probability that a cone will land upright. To explain why the relative frequency is only an approximation of the true probability of an outcome, let's consider tossing a coin, which also may result in only two outcomes. This time the probability of each outcome is known. Both are 0.5. Last time I flipped a fair coin 100 times, I observed the following frequencies and relative frequencies. Since we know that the true probability of a coin showing heads is 0.5, we conclude that the relative frequency 0.47 is only an approximation to the true value. Now, if we toss a coin 1,000 times, we would see the following relative frequency distribution table, in which the relative frequencies are much closer to the true values of the probabilities. This phenomenon is known as the law of large numbers, that states that the larger the number of experiments, the closer the relative frequencies approximate the true value. Let's estimate the probability that a randomly selected student owns two cars. To answer this question using the empirical approach, I would have to check on my past experience with the students owning cars. Last time I asked students how many cars they own, I received the following frequencies and relative frequencies. Based on the empirical approach, I may conclude that the probability that a randomly selected student owns two cars is approximately 8%. Note that the relative frequencies are only approximations. Knowing that, I wouldn't say that the probability of a student owning three cars is 0. I would say it is approximately 0 or a very small probability. Also, it is worth mentioning that the more representative the sample is of the entire population, the closer these approximations are for the entire population. For example, if we were to assume that students are representative of the entire population, we can make a statement that the probability of a randomly selected person owning two cars is approximately 8%. So how does one interpret the probability of an event? Let's say the probability of raining tomorrow is 0.2. What does it mean? Or how is such number produced? To interpret, we must understand where the number came from. If the empirical approach was used, then in the past it rained 20 out of 100 days that were just like tomorrow. So the relative frequency and the probability are both 0.2. We interpret this as in the future it will also rain 20 out of 100 days, or 2 out of 10, or 1 out of 5 on average. The problem with such interpretation is the implied assumption that the experiment will continue behaving the same way as in the past, which may not be necessarily the case. Note that in general, we may not know the true probability of an event, which is the case with many experiments whose outcomes are not equally likely. But we just discussed the empirical approach, which is a great way to approximate the true probability of an event.